Hello friends, in last lecture of steel structure we saw what are steel structure, common types of steel structures. It includes roof trusses in factories, cinema halls, railway stations, etc. Crane girders, columns, beam, plate girders and transmission towers. Then we see advantages and disadvantages of steel structures. Then we saw making of steel, then physical properties of steel. What are the physical properties of steel? Density, models of elasticity, Poisson's ratio, then toughness, temperature, corrosion, hardness and fatigue stresses in steel structure. Then common types of steel structures like I, T, channel section, angle section, steel bar and examples of various sections. Then also we saw the choice of section, on which basis we select the angle section for steel structure. Then the loads coming on steel structure and the IS codes used for various types of loads we saw in last lecture. Today we see the basic terms related with steel structure as per IS 800/2007. The design of steel structure is mainly based on limited design method. The IS standards or IS 800 standards applies to general construction using hot rolled steel sections, joints using repeating, bolting and welding. Specific provisions for bridges, chimneys, cranes, tanks, transmission line towers, bulk storage structures, tubular structures, cold form light gauge steel sections, etc. are covered. This standard gives only general guidance as regards the various loads to be considered in design. For the actual loads and load combinations to be used, reference for load combinations or different kinds of loads: IS 875 for dead load, live load, snow and wind loads, and IS 1893 part 1 for earthquake loads. In this lecture we will see the basic terms using steel structure or different types of structures as per IS 800/2007. First term is accidental loads. Accidental loads due to explosion, impact of vehicles or other rear loads for which the structure is considered to be vulnerable as per the user. This is known as accidental load. Then occupying loads. Occupying loads is a live or imposed load acting along with leading imposed load but causing lower action or deflection in the structure. This is load with main or leading imposed load acting on a member. Third term is action effect or load effect. The internal force, axial shear, bending or twisting moment due to external action and temperature load is known as action effect or load effect. The effect caused by the internal force, axial shear, bending and twisting moment. Then next term is action. The primary cause for stress or deformations in a structure such as dead, live, wind, seismic or earthquake or temperature loads. The basic primary cause of stress occurred in a structure due to different kinds of load is a action of that load on that load. Next term is actual length. The length between center to center of intersection points with supporting members, or the cantilever length in the case of freestanding member. The actual length of any member is the center to center distance of intersection of points. The center to center distance between two supports on which the member will be placed, that is actual length. The next term is beam. A member subjected to bending, mostly it is horizontal, is known as beam. It is compressive, it is tensile member in the structure. Next term is bearing type connections. Connections made using bolts in snug tight conditions or rivet where the load is transferred by bearing of bolt or rivet against plate inside the bolt hole. These are the connections basically of riveted connections in which the two members are joined using rivets and the bearing of bolts or rivet against plates inside the bolt hole is known as bearing type connections. Next term is brass member. A member in which the relative transverse displacement is effectively prevented by brassing. In that is the example of brassing is stacking or providing plates in two vertical members to avoid the transverse displacement of the member. It may be of timber, steel. In steel structure we saw the steel brassing. Next term is brittle cladding. Cladding such as asbestos cement sheets which gets damaged before undergoing considerable deformations. Next term is buckling load. The load at which an element, a member or a structure as a whole either collapses in service or buckles in load test and develops excessive lateral deformation or instability in a structure. Buckling is when the member is buckled due to the load coming on it and the structure becomes instable or the deformation is happen in that member, that is known as buckling load. Then next term is buckling strength or resistance. The force or moment which a member can withstand without buckling is known as buckling strength or resistance of that member against buckling. Next term is build-up section. A member fabricated by interconnecting more than one element to form a compound section acting as a single member, in which two type of elements are joined and the form member will act as a single member is known as built up section. Next term is camber. Intentionally introduce pre-curving usually upwards in a system member or any portion of a member with respect to its chord. Frequently, camber is introduced to compensate for deflection at a specific level of loads. Mostly the common example of providing camber is in pavement or roads. On roads, the upper pavement is in the form of curve, that is camber. It is basically provided for compensating the deflection at specific level of loads or load coming on that member. Next term is characteristic load action or characteristic load. The value of specified load or action above which not more than a specified percentage, mostly 5% of sample of corresponding load or are expected to be encountered, that is known as characteristic load. Next term is characteristic yield or ultimate stress. The minimum value of stress below which not more than a specified percentage, usually 5% of corresponding stresses of samples tested are expected to occur, that is known as characteristic yield or ultimate stress of that material. Next term is column. A member in upright or vertical position which supports a roof or floor system and predominantly subjected to compression. Column is mainly compressive member or compression member. We design column as a compression member and mostly it is vertical which supports a roof or floor system. Next term is compact section. A cross section which can develop plastic moment but has inadequate plastic rotation capacity needed for formation of a plastic collapse mechanism of a member or structure. Next term is constant stress range, that is the amplitude between which the stress ranges under cyclic loading is constant during the life of the structure or structural element. The amplitude is like in for wavelength of light we saw the amplitude, the upward, or in sine curve we saw the amplitude in which the amplitude is coming in particular interval. In cyclic loading, when cyclic loading is applied on a member, the constant stress range for particular interval is occur. Next term is corrosion. A electrochemical process over the surface of steel leading to oxidation of the metal. It causes mainly rusting of steel and it reduces the strength of steel. Next is crane load. The horizontal and vertical loads from the crane working on steel structure. Next is the basic term. Next is cumulative fatigue. the total damage due to fatigue loading or varying stress range. The fatigue load is cyclic loading which comes in particular interval ups and down. The stresses caused in a member due to cyclic loading are known as fatigue stresses, and the cumulative fatigue is total damage due to fatigue loading or varying stress ranges. Next term is cut-off limit, the stress range corresponding to the particular detail below which cyclic loading need not be considered in cumulative fatigue damage evaluation correspond to 10⁸ numbers of cycles in a most cases. Then next term is dead loads, the self weight of all permanent construction and installations including the self weight of all walls, partitions, floors, roofs and other permanent fixtures acting on a member. Then next term is deflection, it is deviations from the standard position of member or structure. Then design life, the time period for which structure or structural element is required to perform its functions without failure or without damage is known as design life of any kind of structure. It may be of RCC or it may be of steel or other materials. Next term is design loads or factored load, a load value obtained by multiplying the characteristic load with a load factor is known as factored load. Then design spectrum, the frequency distribution of the stress ranges from all the nominal loading events during the design life is known as design spectrum or stress spectrum. Next term is detail category, designation given to a particular detail to indicate the curves to be used in fatigue assessment. That curves are known as SN curve or south north curves in a fatigue assessment, that is detail category. Then next term is discontinuity, a sudden change in cross section of a loaded member causing a stress concentration at that location is known as discontinuity. An uniformity in the member or sudden change in cross section of any member by which the stresses concentration are changes. This is known as discontinuity. Next term is ductility, it is most important term for steel. It is the property of the material or a structure indicating the extent to which it can deform beyond the limit of yield deformation before failure or fracture. The ratio of ultimate to yield deformation is usually termed as ductility. Then next term is durability, it is the ability of material to resist deterioration over long period of time, it is known as durability. Next term is earthquake loads, the inertia forces produce inner structure due to the ground movement during earthquake is known as earthquake loads. Then next term is edge distance. Distance from the center of a fastener hole to the nearest edge of an element measured perpendicular to the direction of load transfer. Next is effective lateral restraint. Restraint that produce sufficient resistance to prevent deformation in the lateral direction. Then next term is effective length. Actual length of a member between points of effective restraint or effective restraint and free end multiplied by a factor to take account of the end condition in buckling strain calculation. Next is elastic cladding. Cladding such as metal sheets that can undergo considerable deformation without damage. Then elastic critical moment. The elastic moment which initiate lateral torsion buckling of a laterally unsupported beam. Then elastic design. Design which assumes elastic behavior of materials throughout the service load range in designing of any member or structure. Then elastic limit. It is the stress below which the material regains its original size and shape when the load is removed. In steel design, it is taken as the yield stress. And next term is end distance. Distance from the center of a fastener hole or rivet hole to the edge of an element measured parallel to the direction of load transfer is known as end distance. Thank you.